Hi, hello everybody. I just graded your speed worksheets. You did really well. Just make sure you have units on everything and the correct unit. That's the only thing that I could tell you. But other than that, you did great. So this is section 3, acceleration. I'm going to go over everything, what it is, and then tomorrow I will give you another video on how to do the math. This one's just a little bit more, just one more step up, so it's not going to be hard either. All right, so this one's about acceleration. Acceleration is the rate at which velocity changes. Remember, velocity is speed and direction. It's a vector, so it has a magnitude and a direction. Velocity is a combo of speed and direction. Just said that. Acceleration can be described as changes in speed, changes in direction, or changes in both. That's Sarah getting water out of the fridge. And then just spilt it all over. Okay, are you done? Okay. Acceleration can be described as changes in speed, changes in direction, or changes in both. Acceleration is a vector. Again, it has some magnitude, in this case velocity, and then it also has a direction. All right, so let me talk about those three things, how they can be. So the first one is changes in speed. So acceleration can be either caused by positive, increasing change in speed, so they're going faster, or it can actually be by negative, decreasing change in speed. So most of us use the term acceleration by meaning going faster. But acceleration just means moving. So you can have positive acceleration, meaning speeding up, or you can have negative acceleration, which means decreasing your speed. Acceleration just means moving. All right, the constant speed would make the acceleration 0. So, like if I put it on cruise control in my car, it would just be my acceleration would be 0. I'm not speeding up, I'm not slowing down. Deceleration is actually the correct term for an acceleration that slows an object speed. Okay, so you can decelerate. Let's see. Free fall is the movement of an object toward Earth solely because of gravity. So these are things falling down. This is a rock that falls off, or a tree limb falling off of a tree. This is a rock that you drop from a high bridge, something like that. The unit for speed or velocity is meters per second, and the acceleration unit is meters per second per second. And you can write it usually like this, meters per second squared, because it's meters per second per second. So remember, it's velocity and then it is time. Velocity is the speed and then at the rate that it's changing. That's acceleration. So objects falling near the Earth's surface accelerate downward at a rate of 9.8 meters per second squared. That's gravity. You need to make sure you write that down. That will be on many tests. You're going to need to know that because when we get to some of the problems, you're going to have to know gravity. Please write that down. Box it, highlight it. You've got to know gravity. 9.8 meters per second squared. You should be hearing that in your sleep. All right, the next one is changing in direction. So what we just talked about was the way you can change in speed. So you can speed up, you can slow down, okay? Or you can stay the same, which is 0 acceleration. The next one is changes in direction. So even if you're at a constant speed, you can still accelerate. Changes in direction means you're accelerating. So like if I was on a carousel, okay, so like say you're on a carousel at the mall or at the one at the zoo. Once it gets started, it's at the same speed the entire time, right? But it's changing direction because it's in a circle and it's changing direction constantly. So that is acceleration. It's not changing its speed once it gets going. I mean, I know it's speeding up when you first get on and slowing down when it ends, but while it's going, it is accelerating because it's changing directions constantly on a carousel. All right? And then you can change speed and direction. So this would be examples of a roller coaster or a car down a windy road. So if you are going down a windy road, hopefully you're going to brake when you have sudden turns, and then probably speed up after you get through that turn, but then you're also kind of swerving to the right, swerving to the left. In a roller coaster, you're going up, you're going down, you're going side to side, you're speeding up, you're slowing down, you're stopping, all those kind of things. So changes in speed, changes in direction like a carousel, or changes in both, which means you are changing your speed constantly and then your direction. Okay. Now the next one is constant acceleration. The velocity of an object moving in a straight line changes at a constant rate when the object is experiencing constant acceleration. Constant acceleration is a steady change in velocity, and velocity is speed, right? So this is an example of an airplane taking off. Like when it first takes off. When it takes off, it's constantly speeding up. Okay, and so that's constant acceleration. And again, these are pictures all in your book. Calculating acceleration. This is going to be our next formula. So acceleration is the rate at which velocity changes. So velocity is meters per second already, and then this is the rate at which velocity changes. That's why it's meters per second, which is velocity, per second, which is the rate at which it changes. Okay, so the formula is A equals VF minus VI divided by T. The VF is final velocity, what it ends up at, and then the VI is initial velocity, what it starts out as, and then T is time, okay? And usually in seconds. It's meters per second usually. Now you can do other things, but most of the time in this class, it's going to be meters per second per second. The slope of a speed time, I'm going to go over these later. I'm going to do all the graphs that I told you I was going to do probably Friday, okay? But tomorrow I'll have a worksheet for you on acceleration and speed. All right? All right, bye.